Hi, welcome to another video from SQL Maestros, and today I am going to talk about the concept of density. Now in this channel of SQL Maestros, you will actually find a lot of videos related to SQL Server and these concepts like density, predicates, cardinality estimation and selectivity. Many of these concepts are very fundamentals to query tuning. So if you are someone who is diving deep inside SQL Server and are involved in performance tuning and query tuning, then these concepts should be important to you. So as always, let's straight away jump into some demos and understand the concept of density. Let's begin. So if you look at the formal definition of density, it says measure of uniqueness of data in a column. The moment I read this sentence, what strikes me is we are talking about the data in a column. We're not looking at data in totality in a table, but density is measured on per column basis. So let's say you have 10 columns in your table. You're actually talking about the density factor for 10 different columns. In more simpler words, you can say what density really means is how often do you see duplicate values. Now, high density would mean that you have less unique data and low density means more unique data. Density would range from 0 to 1 and the formula is simple. Density is equal to 1 by the number of distinct values in a column. And again, note this again, in a column. So let's look at a simple example and I will show you high density, low density and what really density is used for inside SQL Server. So I'm going to use this database AdventureWorks 2014 and there is a table here, sales order header. Let's look at this table and there are multiple columns. Two columns are of interest to me here. One is revision number and you can see there are a lot of duplicate values there, 8, 8, 8 and it's repeated just so many times. And there's another column here right at the end which is total due and you can see a lot of different variety of values. So of course it has less, it has more unique data comparatively. So if I look at only total due, as I showed you that there are a lot of different variety of values here and revision number has a lot of duplicate data. Now we need to go by the formula to show you the density. So let's look at the count of this object table. And we can see the row count is 31,465. So there are approximately 31,000 rows in this table. And how many distinct values do we have for total due? So I'm going to take total due to begin with. And if we execute this count distinct total value, we see that we have 4754 unique values. These are the distinct values in total due. So which means the remaining records are just duplicates of these distinct values. Now reminding you again about the density. So density ranges from 0 to 1 and the formula is 1 by the number of distinct values in a column. So if I have to calculate the density factor for total due column, I would just simply do select 1 by the number of distinct values in a column and I get a value of 0.000210. So this is this is your density factor for total due. And if you look at revision number, which as I said earlier and I showed you that it has a value of 8 and it has been repeated so many times and our row count of course is 31,000 and if you look at the count distinct value of revision number, you just have two distinct values there, which means the density is going to be really very high. So if I select 1 by 02, you get 0.50, which means if assuming there was just one distinct value, which means there was all duplicate records, you would get a value of 1 and that's the highest you can get. So as the density goes higher, you have less unique data and as the density goes lower, you have more unique data. So keep this always in mind. High density means less unique data and low density means more unique data, which means for our total due, we had very low density because we had more unique data and we had for the revision number, the density was really high and we were just touching like 1, it was 0.5, which means we have less unique data. Now let's look into where exactly is density is being used. So density is used by the query optimizer when it's evaluating multiple plans, and of course it is used for cardinality estimation. And I'm going to take total due as an example to show you where exactly is this density value stored. So I am going to create statistics for total due. I'm manually creating statistics. Of course, statistics are automatically created for indexes or whenever you use a particular column in your query, in your select query. And of course, auto create stats should be turned on. So when I create stats for total due, and now let me show you the statistics for total due using the command dbcc show stats, you are going to see that for total due, these are a lot of metadata about the statistics, and one of the records here talks about density. So the average length is 8 and this is the column total due, and look at the density, it is 0.000210. So this is the same number that you got here when we manually computed the density, and this gets stored in your statistics. Now how is the query optimizer using this value? This is beyond the demo in this video, but I am definitely going to record a couple of more videos which you will eventually find in this SQL Maestros YouTube channel, and understand and learn how the query optimizer uses the density factor to compute cardinality estimation. So hope there was something new for you to learn here. Well, that's it from me for the time being. Thank you very much for your time. Hope this video was worth your time and you have learned something new. See you in another video very soon. You can follow me on Twitter, _Bansal, and hope to talk to you soon. Thank you very much.